Alright, so hello everyone, welcome back to yet another tutorial on this AutoGrad from scratch in C. So previously in our video, we saw how PyTorch AutoGrad works. We draw computational graph, and we've observed that how it goes node by node, and it keeps track of all the previous operations in tensors, parent tensors and everything. So today we'll be trying to implement some similar kind of things. So we already have a tensor defined over here. Okay, so if I show you our current tensor class, tensor structure looks like. So we have shape, we have stride, we have dimensions, and we have data. So we need to modify some new uh, we need to modify it with some new parameters in order to keep track of the computational graph, the parents, the operations that build a certain tensor and everything, right? Let's just go ahead and modify our tensor, and we'll be modifying our tensor important methods as well. For example, tensor matmul, it will keep track of everything. So we'll be having two tensor matmul operations. One is for backward pass and one is for forward pass. So for forward pass we'll be building our computational graph, and for backward pass we'll be computing the gradients, and we'll be updating those gradients in our optimizer step. So let me just show you what other parameters do we need for computing the computational graph. So for example, first of all, we'll be needing some operation data structures. This will store a well, why don't I just go ahead and create a new file in order to first check it, and if everything works fine, then we'll be we'll be appending this to our existing script. So what do we have? Tensor.c. So tensor create new. Let me just copy this function. We'll be modifying this exact function right here, and I'll need IO edge lib assert edge. And for headers, custom headers, I'll be including arena.edge, and what else? Config maybe. Alright, so this is our tensor create new method. Let's define a tensor structure over here as well, because it's just a test file. We'll be running the same file to first check the functionality and everything works okay. Then we'll be integrating this to our main script. So alright, so this is going to be type def structure tensor tensor, and has all the previous methods. Let me just copy from here and save some typing time. Alright, so yeah, just put them all here. Okay, and now we have some new parameters for AutoGrad, and these will be first of all op creators, and let's just call them operations. Let's just call them operations. That makes more sense. And what do we have here is tensor parents, tensor grad, very important one, tensor, and what else? Yeah, int number of parents, and yeah, so we have operations, we have tensors, we have grades, and we have, yeah, requires grad. So bool requires grad. Perfect. This is our tensor class. Let's define the op data structure as well. So type def structure op, and this will be pointing to the previous method. So we're gonna need void void backwards and point to tensor struct self, and let's define the prototypes here as well. So tensor type def structure tensor. This is called forward declaration C. So yeah, looks fine, and let's just test this create method. So int main. Oh man, create arena a malloc. It takes size. Why don't I just go ahead and copy this as well? Arena.c. Yeah, yeah. This is something I need. Okay, fine. Alright, so let's just create our new modified tensor. So tensor x would be tensor create new. It's going to take arena. It's going to take ndim and shape. And let's try to print something now. Parents x. Yeah. Okay, some typo, I guess. Hash and boom. Alright, so expected semicolon here. Turn off typos. So type def, structure, tensor. Okay, this looks fine. Okay. Two or more times. What is wrong here? So we've defined everything. Let's create the prototype for functions as well. So tensor create new. It's gonna take arena a and dimensions and okay, some warning, data definitions, no type storage class. What actually is wrong here? I have no clue. Let's just check. Should I not use the struct here? Why? Oh, to my surprise, it has solved the problem. So number of parents 0, data definition is noted by. Okay, so let's check this warning as well. So our script is working. I'm just curious. What is this warning? Is this some typo? Are you serious? 9. Okay, and what does this actual data type is? Boom. Alright, so we're getting number of parents equals 0, which means our modified parameters are working fine. Now, here comes the important part. So now we need to write tensor matmul, right? Let me just go ahead and do it. So tensor matmul forward, it's gonna take arena. It's gonna take obviously tensor A, tensor B, and it's gonna do the following things. So multiplies tensors A and B, and then populates the operations, pointer to the back function, keeps track of parents, alright, so it's gonna create the operations, create a graph, keeps track of the operations that are applied on the tensors, and return a pointer of the backward function, keeps track of parents, tensors that have created this specific tensors, and what else? Yeah, finds the gradients of tensor, but this will not do this, right? So we only have to do these two things, right? So first of all, let's check the dimensionality match. So int a rows equals a shape 0. Alright, so we have A rows, A columns, B rows, B columns. So assert A columns. Make A B, right? And if A uh, requires uh, uh, so we're checking that if any of the matrices A and B has requires grad equals true, which means that we need to find the gradient, and we need to update its values, its weights with the gradients, right? With the calculated gradients, right? So we need to check if either one of is true or not. So if any one of both these is true, then tensor, which will be returning from this function. So tensor out is going to be arena log arena, and size would be no, no, no. Um, a rows in out shape columns would be B columns. So this comes from matrices properties. So if you, when we multiply two matrices A and B, the resultant shape would be rows of A multiplied by columns of B, right? Perfect. All right, so let's just define, let's just initialize this out matrix as well. So we have out equals arena a log. Sorry, this will be like yeah, tensor create. Let's just use the method new and arena dimensions would be same, and out shape. Perfect. And now, yeah, so if any one of them is true, out requires squared will always be true. Will also be true. And let's define out parents would be 2, out parents 0 to next would be A. First next would be B. So we're keeping track of the parents of this output matrix, and then we have um, let's say um, let's define out size. So it would be a shape 0, shape 1. And now let's define AutoGrad as well. So AutoGrad would be arena log um, And now let's define the operations. So op equals op backward would be tensor uh, and let's just define its prototype here. Tensor yeah. And we'll apply some loss and we'll define it later. Okay, alright, so out operations equals op. Fine. Uh, mm, uh, and then we'll have this is not, this is C equals sum, and then I guess this should be it. And let's check if this is working. So uh alright, so I've pulled an all-nighter and I'm feeling like stoned right now, and let's see if this works or not. Alright, so A, dimension, and shape. Okay, so we'll be having tensor C, tensor matmul what does matmul take? Yeah, tensor matmul forward. Yeah, so tensor matmul x, y, and a. Okay, so for z size, x, shape, 0 times y shape 1. Mm-hmm. Mm-hmm. Okay. Okay, okay. Tensor A and tensor B also need to fix this thing as well. Oh, okay. This should work. Okay. Okay. Conflicting types. Arena A and B. Um, okay, so um, okay, so in dimension, yeah. Out. What's wrong here? Okay. Mm, let's just do this. Damn. Still, there's something wrong. out and declared now. Dear me. Yeah, that's right. Will this work? Parents equals 2. Forgettable warnings for now. Yeah. Yeah, there it is. B data k times b comms plus c. Ah, okay. Mm-hmm. Okay, so yeah, for sure we cannot make both these equal. So I think shape A. Let's define this. So shape X. This will be like let's say 16, 32, and shape Y. This will be something like 32. So output shape will be 16 cross 16 now. Tensor matmul backward assertion failed. Why? Columns of first equals rows of second. Oh. Segmentation fault. Parents equals to okay, let's just quickly search it.